Hi, I'm Sean Gannon, and this is MinuteMath, and today we're learning about using the zero exponent rule of exponents.
MinuteMath, when you need help you use MinuteMath.
Okay, so what is the zero exponent, right? It's not going to always be out there, like x to the 0 power, but we're going to apply that, and when we simplify them, we can use it. So, example of this. Sometimes we'll see stuff like this. T to the 8th power divided by t to the 8th power. Now, we always know that a number divided by itself is equal to 1. So where does the zero exponent come in here? Well, we know by our quotient rule of exponents, right, that we have the same base. This is t to the 8 minus 8th power. Well, 8 minus 8 is 0. So we have t to the 0 power, and now, well, it's just 1, right? Anything to the 0 power is 1. So now we can apply or learn the zero exponent rule of exponents. For any non-zero real number a, the zero exponent rule of exponents states that, now remember, any non-zero real number, that's what a is, states that a to the 0 power is just equal to 1. Fairly simple. Now, this is useful when simplifying expressions or solving equations, this rule. So let's get some examples out here. I think I fit the first one right here. A. Let's zoom in here. We have, I believe, c to the 3rd power over c to the 3rd power. Now this is a very similar example from what we started with. We apply the quotient rule, and it's, well, c to the 3 minus 3 power, which is c to the 0 power, and now we can apply our zero exponent rule, and we know that's equal to 1. Not too bad. Let's try b. Okay, so b here, we have negative 3 x to the 5th power over x to the 5th power. Okay? Well, simplifying this, I like to break it apart if I can. This negative 3 is being multiplied by x to the 5th. So if I put it out here, we can rewrite this whole thing as such. Negative 3 times x to the 5th over x to the 5th. And now this looks very similar to what we had for question A. X to the 5th over x to the 5th, we apply the quotient rule, so we have negative 3 times x to the 5 minus 5 power. 5 minus 5 is 0. Negative 3 times x to the 0 power, and you can see where we're going. X to the 0 power is 1. Negative 3 times 1, and we just have negative 3 as our final answer. Okay? Let's try the next one. Okay? We have c here, and this one's a little more complicated. J squared times k to the 4th power over j squared k times j squared k to the 3rd power. Okay? So, first thing I want to do is, I notice we have really a base of j squared times k. I kind of see that as my base here. Now, what I notice though is in the denominator I see the product rule happening. So I'm going to kind of simplify that. Keep the numerator the same. J squared k all to the 4th power over here, product rule states we add the exponents, and remember this one has like an exponent of 1. So that, when we add it together, we have j squared k to the 1 plus 3 power. I know what's tempting, okay? Right when you started this problem, I should have mentioned that. A tempting thing is to try to multiply all this out, but sometimes by understanding our rules, we can simplify much quicker, and you'll see. 1 plus 3 is 4. We have j squared k over 4 over j squared k to the 4th power. Now look at this. We have the same base here. That base is a little more complicated than we're used to, but it's j squared times k as a base. the zero exponent rule is going to apply. Well, after we do the quotient rule first, but eventually I'm getting ahead of myself. Same base, we can subtract the exponents now. And sometimes by keeping things a little separate, but in our parentheses, we can make this problem a lot easier than if we tried multiplying all this out. So, quotient rule, subtract the exponents, j squared k to the 4 minus 4 power. 4 minus 4 is 0. We have j squared k to the 0 power, and there we have it, right? We basically applied the zero exponent rule, and we just got 1 here. Oh, that whole complicated thing became 1. Let's get through our last one. D. 5 times r s, don't judge my s's, squared to the second power, all over r s squared all to the second power. Okay? So we want to apply our rules here to see what this simplifies, and we'll get to the zero exponent rule. Okay? Well, again, like we did earlier, right, with b, this 5 is really going to be multiplied by our bases. Our base here is rs squared. So to show that, we have 5 times rs squared all to the second power over rs squared to the second power. Okay? Now, since our base is rs squared, okay, we can apply the quotient rule. They're the same here. So we have 5 times rs squared to the powers that get subtracted, 2 minus 2. 2 minus 2 is 0, so we have 5 times rs squared to the 0 power. And now we can apply the zero exponent rule. Rs squared to the 0 power is just 1. 5 times 1. And 5 times 1 is 5. And so that is our final answer. Again, if you like this video, like the button down below. Hit the like button. Hold on. Hey, honey. Sorry, my daughter's talking to me as I'm trying to teach her. Hit the like button down below and subscribe to our channel. And this helps us make videos for everyone. And as always, thanks for watching.
Math, MinuteMath. When you need help, you use MinuteMath. MinuteMath, MinuteMath. When you need help, you use MinuteMath. MinuteMathTutor.com.